Welcome to the Deep Dive. Today we're digging into a topic that honestly sounds a bit backward at first glance. Destructive software testing.
Yeah, the name itself is provocative, isn't it?
It really is. The whole idea is about intentionally trying to break software, deliberately making it fail. Which, sounds kind of crazy. Why would you actively try to crash something you've built?
Well, that's the fascinating part. It seems counterintuitive, but this approach, this deliberate stress testing, is actually key to building much stronger, more resilient software in the end.
Stronger through breaking. Okay.
Exactly. It's about finding those weak points before they cause real problems for users, identifying how it could fail so you can prevent it.
Okay, let's unpack that then. What exactly is destructive testing in the software world? What does it mean to intentionally make an application fail?
So at its core, it's a quality assurance method. You're essentially poking and prodding an application, trying to force it into an error state, maybe even crash it.
To check its robustness, you mean?
Oh, precisely. It's about checking its robustness. See, most testing checks if the software does what it's supposed to do, right? Following the happy path.
Like the requirements.
Destructive testing slips that. It focuses specifically on how the software handles the unexpected, unpredictable user actions, weird inputs, system stress, that kind of thing.
Trying to figure out its limits.
Yeah, pushing the boundaries. And what's interesting is you don't always need intimate knowledge of the original specs to do it effectively.
Oh.
Sometimes a fresh perspective, someone just trying to, mess with it, can uncover issues the original designers never thought of.
Okay, so that touches on the why. Why would a developer or, say, a company want to do this? Deliberately crash their own product? It still feels like you're making extra work.
Well, the payoff is significant. The main reason is to really understand how your software behaves under duress. When it's used improperly, when it gets bad data, does it just fall over?
Or does it handle it gracefully?
Exactly. Does it maybe log an error and shut down cleanly? Or does it crash hard, potentially corrupting data, maybe even affecting other systems?
Ah, okay. So it's about stability.
Fundamentally, yes. Checking the robustness, the resilience of the product. It's about proactive failure finding. You want to find those nasty surprises before your customers do.
Because when customers find them?
The consequences can be much, much worse. Reputational damage, data loss, you name it.
Makes sense. So when you're doing this type of aggressive testing, what specifically are you looking at? What are you checking for beyond just, yep, it crashed?
Good question. You are, of course, checking that it behaves properly under normal conditions first, but then the focus shifts.
To the improper stuff.
Right. Improper software behavior, improper usage patterns, and a big one, improper input data.
Can you give an example, like putting text where numbers should go?
That's a classic one.
Yeah.
Or extremely long inputs, special characters, maybe SQL injection attempts if it's web-based. What happens if you feed a date field something completely nonsensical?
And the goal?
The software should ideally never process or accept clearly invalid input. It should reject it cleanly.
And even if the input is weird, but maybe technically valid?
Even then, the software should always produce proper, predictable output. Or at least fail safely with a clear error message. It shouldn't just, go haywire or expose internal data.
Maintaining integrity, basically.
Yeah.
Even when someone's actively trying to trip it up.
That's the core idea.
Okay, this is getting really interesting. How do testers actually do this? How do they go about intentionally trying to break the software? Is it just random clicking and typing?
Sometimes it might look like that from the outside, but no, it's usually quite systematic, even though the goal is to induce failure.
So there's a method to the madness.
Absolutely. It involves things like designing specific, often harsh test scripts and scenarios, executing them, carefully logging any bugs or crashes, raising those bugs, and tracking metrics.
There are different techniques.
Oh, lots. One common one is called failure point analysis. It's kind of a structured brainstorming session, a system walkthrough where you deliberately think about, okay, what could possibly go wrong here? And here. And here.
Like preemptive troubleshooting.
Sort of, yeah. Another great one is tester peer review. You get a tester who isn't familiar with a specific feature to try and break it. They often come at it from angles the original team missed.
Fresh eyes again.
Exactly. You can also involve end users through business reviews of test cases. They have a knack for finding bizarre, real-world scenarios developers might not anticipate.
Because they use it differently.
Right. And sometimes, honestly, the simplest way is just to give the software to someone knowledgeable and say, here, try your best to break this, and then carefully analyze how they tried and what happened.
So it's structured, targeted chaos, not just random banging on the keyboard.
Pretty much. It's about intelligently probing for weaknesses based on understanding potential failure modes.
You mentioned standard testing methods, too. Can they be used destructively?
Oh, definitely. You can adapt many standard methods. Take regression testing. Usually that's just checking if new code broke old features. In a destructive context, you might hammer those old features with extreme inputs after a change, trying to provoke not just a simple break, but maybe a cascade failure or resource leak.
And things like security testing.
Security testing is inherently a bit destructive, right? You're trying to breach defenses, but you can apply that mindset more broadly. Even smoke testing, which is usually just a quick check to see if the main functions work.
You could push those main functions harder.
Exactly.
Learn.
Flood the login screen, try unusual characters and core fields. It's about using existing frameworks, but with that specific intent to find breaking points, not just confirm functionality.
Wow. Okay. So this whole deep dive really highlights that looking for failure, actively seeking it out, is actually a path to strength in software.
It truly is. It shifts the perspective from just building features to building resilient systems that can withstand the unexpected. It's about anticipating failure to prevent it.
Embracing the potential for breaks to make something ultimately unbreakable, or at least much harder to break.
Well put. It's a powerful paradigm shift.
So as we wrap up, that leaves us, and you listening, with a thought.
Yeah, it makes you wonder, beyond just code and software, where else in life could this principle apply? Where else might intentionally looking for and understanding potential points of failure actually lead to greater strength, more resilience?
Something to definitely mull over. Thanks for joining us on this deep dive. We'll catch you next time.